All right, let's talk about a mistake that so many of us make, especially early in a project. We get seduced by database patterns that feel super flexible on day one, but man, do they become absolute catastrophes down the line. We're going to dive right into it.
Just let that one sink in for a second. If you write some bad code in your app, okay, you can refactor a component. A messy API, you can version it and move on. But a bad database schema, especially once it's full of real production data, that's not a simple fix. That's like performing open-heart surgery on the foundation of your entire application. The stakes are just incredibly high.
And this really gets to the core of the issue, what we're calling the day 1 versus day 100 problem. A pattern that feels so clever and easy on day 1, when your database is nice and empty, can morph into a performance-killing monster by day 100, once you're dealing with the scale and messiness of the real world.
This slide just lays it out perfectly, doesn't it? On day 1, your brain is telling you, this is awesome, it's so easy to code, it's super flexible. But fast forward to day 100, and that very same choice is now a massive performance killer. That simple and fast solution now needs that high-risk surgery we talked about just to fix it. And that dynamic flexibility? Yeah, that's turned into an absolute data integrity nightmare.
So let's meet our first villain. It's a classic, a real regular offender, storing a list of values, think product tags or sizes or colors, all jammed into a single string column. We call it the comma-separated catastrophe.
And look, at first glance, the schema seems harmless, right? You can just picture the thought process. Why would I create a whole separate table for colors? That's overkill. The front end just needs a string anyway. I'll just toss them in a varchar. It feels so efficient, but trust me, it's a trap. And this is exactly where the problems really begin. This simple design completely violates a fundamental rule of database design called first normal form. All that means is that every column should hold a single, indivisible piece of information. By cramming a list into a string, you're essentially hiding the real structure of your data from the database. You're tying its hands behind its back.
So what's the immediate consequence? Well, let's say you want to find all products that are available in blue. The clean, fast, obvious query on the left, it just doesn't work. It's looking for a row where the entire string is exactly blue, not one that contains it. So you're forced to write that ugly thing on the right, using like with wildcards, and that is a performance disaster. That leading wildcard makes your database indexes completely useless, forcing a full scan of the entire table every single time.
And if the performance hit wasn't bad enough, here's the next problem. String matching is dumb. It has no context. Your query for blue doesn't just find products that come in blue. Nope, it also finds dark blue, blue-green, and maybe even a completely unrelated product called blueberry. You're just flooded with false positives, making your search results unreliable and your application code a tangled mess of filters and exceptions.
And it gets worse, because your data quality starts to rot almost immediately. Since it's just a text field, there's absolutely nothing enforcing a consistent format. You'll get extra spaces, wrong delimiters, double commas, inconsistent casing, you name it. And now, all that logic to clean up this mess has to live in your application code, which is the last place you want.
Okay, but this is the most terrifying problem of all, the race condition. Just imagine two users editing the same product at the same time. User A reads the colors. At the same time, user B reads the exact same colors. User A removes red and saves the result, blue-green. But then, user B, who is still working with that old data, removes blue and saves their result. The final value is now red-green. User A's change? It was just silently overridden. It's gone. This is called a lost update. And the scariest part is, you won't even know it's happening until your customers start calling, wondering why their data is vanishing into thin air. All right, let's move on to our next anti-pattern, which takes this whole flexibility idea to a really dangerous extreme. It's often called the Entity Attribute Value Model, or EAV. And the promise is ultimate flexibility by creating one giant generic table that can hold any kind of data you can imagine.
The trap here, and it's a big one, is that you are quite literally building a database inside your database. You're taking decades of incredible database optimization, the engine's power to enforce data types, constraints, and efficient structures, and you're just throwing it all away for this illusion of flexibility. And what's really wild is how this visualizes the problem. In a normal, sane schema, one product is one row. Simple. But in an EAV model, that same single product just shatters into 20, 30, or even more rows in your database, one for every single attribute. Now, just to reconstruct that one product, your database has to go find and piece together all of those individual rows.
And because every single value is just stored as a simple string, you lose all type safety. The database has no idea what the data is supposed to be. It can't stop someone from entering a negative price or the word free into a field that should be a number. It can't check if a data is even real or if stock status is a proper true or false. Your data quality just erodes instantly. So let's put this to the test. Let's ask a simple business question. Find me all the laptops that cost less than $1,000. You write what seems like a totally logical query. Select where the attribute value is less than the string 1,000. Makes sense, right? And the result you get back? Your query happily returns a laptop that costs $12,000. Now, this isn't a bug in your database. This is a direct, predictable consequence of your flawed schema design.
So what on earth is going on? It's something called a lexicographical sort. See, the database isn't comparing numbers, it's comparing strings, one character at a time. And just like apple comes before banana, the string 12,000 comes before the string 800 because the first character, 1, comes before 8 alphabetically. This leads to completely bonkers results for any kind of numerical comparison.
And this problem just gets exponentially worse as your questions get more complex. I mean, just look at this. On the left, a standard SQL query is clean, it's readable, you know exactly what it's doing. On the right, the EAV equivalent is this absolute monster of intersect clauses, one for every single condition. It's incredibly slow, it's a nightmare to write, and an even bigger nightmare to debug and maintain. You are paying a massive complexity tax on every single query you write.
Okay, so we've seen how these so-called flexible patterns can absolutely demolish performance and data integrity. We've clearly identified the trap, so the big question now is, how do we get out of it? How do we reclaim our foundation?
So if these popular patterns are actually traps, what is the right way to build for real, sustainable flexibility?
Well, the good news is the path forward uses well-known, battle-tested patterns. For those lists of items, you use a junction table to create a clean, indexed, many-to-many relationship. For dynamic attributes, modern databases offer powerful tools like JSON-B columns, which give you flexibility while still allowing for fast, indexed, and even type-safe queries. And most importantly, you don't have to blow everything up. There are phased migration strategies to fix these foundational issues without ever taking your application offline.
So as we wrap this up, the real takeaway is to go back and ask this one critical question about your own systems. That shortcut you took for flexibility, is it truly a feature that empowers your application, or is it a hidden crack in the foundation, just waiting for the pressure of scale to break everything apart?